Hello again, everybody. We are back in algebra again. This is the end of week 2. Normally at this point, we'd be just about ready for the first unit test, but we're a little bit behind on that right now. So today we're going to try to finish up where we ended from Tuesday with literal equations. Then we get to work on everyone's favorite word problems. Geez. Usually somebody at least laughs about that. Not today. And if we have time, then we're going to start looking at inequalities, single variable inequalities. We'll just have to see how the time goes. So I'm going to start off with, we got to finish the presentation on the literal equations first. Somebody was calling them, who was I talking to yesterday? Somebody was calling them the alphabets. And that's a good way to describe them, because with these literal equations, they are mostly letters. Okay, please mute yourself out there. Whoever just joined us, yes, thank you.
Wait a minute. Turn the TV down. Sorry.
No, just mute. Yeah, there we go. Yeah, there we go.
Wait a minute. I'm trying to mute. Hang on.
I can do it. Okay, you're muted. There you go. All right. The alphabets, the literal equations. We talked about these one-step equations yesterday. Using our opposite operations, we're going to try to get the variable by itself. Here on the left, the variable is x. So we're going to subtract 3. That's a one-step equation. On the right, we're solving for a. We do the exact same thing. We got to get the a by itself, so we subtract b. It's in the same position. The 3 and the b are both positive, so we're going to use the opposite to get rid of them, to cancel them out. We did the same thing on the next one-step equation where division was involved. These fractions are division problems, so our opposite operation that we're going to use on those is going to be multiplication. Another variety is multiplication. 5x equals 30. Okay, we'll divide both sides by the coefficient of x. Our coefficient is 5, so 30 divided by 5 is 6, x equals 6. And if I'm solving the one on the right for b, in the same way that the one on the left is 5 times x, the one on the right is a times b. So a, in effect, is the coefficient of b. I divided by the coefficient of x on the left to get the x by itself. That's the only variable on that one on the left. The one on the right's got 3 variables. Don't know what any of them stand for. It doesn't matter. All we're doing is reorganizing the terms. So if I divide everything on this side, this equation by a, see if I can type in here somewhere. If I divide both sides by a, and let's see, where can I put in a line? Yeah, here we go. I'm dividing both sides by a now. Look what happens to the a's. What's a divided by a? It's 1. We're not subtracting. It's not 0. Anything divided by itself equals 1. I don't care what the term is, what the number is. 500 divided by 500 is 1. 10 trillion divided by 10 trillion is 1. A divided by A is 1. X divided by X is 1. That's why we do this division by the coefficient. So what do you got after you've done that? You got B by itself. And that equals C divided by A. Doesn't seem like a big change, but I know a lot of people struggle with these kind of problems because you don't have any numbers. What I'm trying to get you to focus on right now is the fact that the process is exactly the same. In the same way that we worked on getting this 5x down to a single x. And it's pretty similar to what I was just talking with Jessica about also before class started. We're going to divide by that coefficient, and then we will have our variable down to just a single letter. So here's a two-step equation, a couple of two-step equations. Got 3x over here, minus 7 equals 2 on the left. Got A times B minus C equals D on the right, and it says solve for B. Okay, anybody got a suggestion on what to do there on the left? I don't know if I can type in there. Match like terms. It's an interesting suggestion. I'm not sure what you mean. Because they're on. Go ahead. They're on opposite sides of the equal sign. Somebody said add 7. I like that answer best so far. (3x minus 7 equals 2). Again, remember the goal is to get the variable by itself. So any other terms that are on the same side, you got to eliminate. We got to get rid of them. So at that point now we have 3x equals 9, and that's going to be easy to solve because we have all numbers. So what is the other one again? A, B minus C equals D. Okay. A, B minus C equals D. See how the terms all line up the same way? You got A times B in the second one. You got 3 times X in the first one. You got a minus C in the first one. You got a minus 7 in the second one. We got a total. We got equal signs in both. One of them equals D. The other one equals 2. We don't care whether they're letters or not, because the process is the same. I still have to cancel that C term from the left side, get it over to the right. Okay. Now I got A times B equals D plus C. It's essentially the same thing I did over here on this other one. Because if I rewrite that second line, it's going to say 3x equals 2 plus 7. So exactly the same. Same first step, opposite, get rid of a term. Now the last step for both of these is going to be the same also. I got to do some division because I got to get the X by itself on that one on the left, and the B by itself on the one on the right. Now, since I don't know what D plus C is, that's a quantity. I don't really care what it is either, but I can't separate them. So where we've got mostly numbers now, I just divide by 3. On the right, I'm going to divide by A because the A's will cancel. 3's will cancel on that side. X equals 3. 1 on the right now, B equals D plus C divided by A. Just reorganize the terms. A lot of times when you're working with scientific formulas, you have to do that. You may know a different part than what you typically solve for. Well, that's okay. Plug in what you know and work with the rest. Okay, questions, anybody on how I did that so far?
No, thank you.
No.
Two-step equation. See if we got another one. Oh, yeah. Lots of fun here. Solving for A on the right. That's in a quantity. That's in A plus M. It's also part of a complex fraction. Well, the N on the left is tied up in a complex fraction also. And our first step for both of these is going to be the same. We've been talking about steps that we can take to get rid of fractions, to cancel out fractions. Anybody remember what that is? I heard somebody say multiply.
Multiply. Yeah.
By what?
By
Just add-
6.
Oh,
Yep, we're going to multiply by the denominator, which on the left-hand side is 6, on the right is 7. Pretty good so far. Guys are catching on. See if I can make this make sense over here. Minus 4 plus n is -1. And that is 6. So there's our quantity. The other one was B equals A plus M over 7. It's -1 in the original on the slideshow. So if I multiply both sides by 6, what happened to my controls? Let me do this again. There we go. Multiply both sides of this one by 6 times that whole quantity. On the other one, I'm multiplying by 7. Cancel, cancel. Everybody loves to talk about cancel culture these days. So can we apply that to algebra? I don't know. -1 times 6 is -6. On the other side, we got 7b equals A plus M. All right. Questions, anybody? What next?
subtract the numbers.
Subtract the numbers. I'm not sure.
Take +4 to both sides.
+4 to both sides. Correct. We're not subtracting. We already have negative numbers. We got to use opposites to cancel. Right? And that first one, the n, is already on the left. You don't need to do anything with that. We're trying to get the chosen variable all by itself. No other terms on the same side. So you leave it wherever it is and deal with everything else around it. So I want to add 4 to both sides of this one. And I'm basically going to do the same thing over here, only now I'm going to subtract m. Did I do that right? Is that the right? Yep. It's supposed to be. Does that make sense why I did that?
Yeah.
Well, I don't know how to make this any brighter. I don't know how to darken any of this up. This is as bright as the projector goes. Every question is legitimate. M?
Well, and there's an imaginary one in front of him.
It doesn't matter.
Right, well, he said, are you subtracting it from B or are you subtracting it from 7?
Neither. Doesn't matter. I'm not subtracting it from B or from 7. I don't know what B stands for. I don't know what M stands for. It doesn't matter. Here, it's canceled. On the left side, what we have is 7B minus M equals A. And that's all you can do. We're not looking, these kind of problems, you will never get a final answer that says N equals 5 or M equals 4 or B equals 13. Because all we are doing is rearranging the terms to solve for a different variable. And this is one of the most confusing things that we run into in early part of algebra. Because everybody gets so locked into the idea, oh, I got to have a number. What is B? What is M? It doesn't matter. Who cares? If I told you what the number, what the letter was, then we could just do the math. We could do the calculation. But this is algebra. We can rearrange terms any way that we want to, as long as we follow the same process. And that's what I'm trying to focus on here. What is the process involved to get a variable by itself? It's the same in every case. We use the opposite operation. This A plus M over 7, that's division. So our opposite operation is going to be multiplication. On the other side, we started with -4 plus N over 6. That's also division. That's a fraction. That's division. So we do the same thing. We multiply and get rid of the fraction. Done the same processes in both of those at the very top. Multiplied both of them. Now I don't have any more complex fractions to deal with. The second level here is to remove any other terms that aren't the variable that we're trying to solve for. But -4 has to go on the one on the left. The M's got to get moved. It's got to get canceled, shoved to the other side. Yeah.
None of the letters in terms of like moving them, none of them disappear. They all stay like where they're at.
Yeah. You can't just drop them because you don't know what they stand for. If I told you that B equals 25 and M equals 11, now you could solve it with numbers. But we don't know. And the fact that they're variables means they could be anything. So that's why if you just think about, it's like shuffling a deck of cards. You know, we're just moving the stuff around, reorganizing, reordering the terms. We can't, none of it disappears. We can't subtract M from B because those are not like terms, right? So that has to stay. They have to stay in the equation.
So as long as you don't get rid of the number or a letter, you're probably right.
Probably, yeah. A lot of times, not always, but yeah. If you treat them the same way that you treat numbers, you should be fine. Because it's the process that's the important thing here. It's not the terms, it's not the numbers, it's not the letters. It's use opposite operations every step of the way. So what kind of a problem is it now? Okay, I understand that it's this kind of problem. I need to use the opposite. You know, then you do that, bring it down to the next row. Okay, now what kind of a problem do I have? Okay, just keep going. Keep using those opposites every row. Somebody had a comment in the chat over here. Exactly, Chance. M could equal anything. Very good. In a minute here, we're going to give you guys a chance to work on a couple of these on your own. Here's another example I think is kind of funny. Anybody keeping track on what's going on with the Mars rover? Have they been able to fly it yet? Because the first attempt, it didn't get off the ground. I think the Martian atmosphere is a little too thin to generate enough lift to fly that thing there, but we'll see. So somebody got cute here and came out. I didn't make this up. Somebody else did. If we're going to solve for M, we're going to subtract R. And then we're going to divide by A, because MA is multiplication. That's M times A. Right? Minus R, not underscore. Minus R. Minus R. MA equals S minus R. I'm doing the same thing in this other one on the other side too. If I could type in there. Nope, don't want to do that. So if I divide both sides by A, that gives me that final answer. I've solved for M. Nope, don't want to do that. The A's cancel on the left, but now I still have to, if somebody would tell me what those other letters stood for, I could solve them. You guys ready to try a couple of these on your own? Yeah, sure. I can sense the excitement.
I'm gonna be honest, I'm totally lost.
Well, we will try to get you totally found here in a minute. So hang on at home here, guys. I got, in fact, let me pull this up. I actually have paper copies to hand out for the people that are here. So if you are at home, the first one I want you to look at is number 7. We're going to do that one first. So I'm going to pause the recording here and hand out these papers. On number 7, does anybody recognize that particular formula from any time in the past in algebra?
I know it, but I can't like pinpoint what it was used for.
Okay. If you also look at number 6, does that help?
That's slope. That's slope intercept.
That is slope intercept. The one in the equation in problem number 7 is what's called standard form. Standard form, and so 6 and 7 are basically together. We start graphing in the next unit, you'll see how important those two equations are. These equations are interchangeable for graphing. And the reason that we do all of this literal equation stuff is because of these two problems. Later on, you'll see if we're going to work with an equation like number 6, y equals mx plus b, that means we have a line that we can graph on an xy coordinate. Well, that gives us the slope, that gives us the y-intercept, it gives us the stuff to work with that we need to make the graph. The equation in number 7 does not have what we need. But if we convert it, we can convert the equation in 7 to be in the same format as the one in 6, and then we can graph it much easier. That's why we do all of this. So who can tell me what we should do with the first step?
Subtract minus ax both sides.
So you're gonna divide
We're trying to solve for y, aren't we?
you're gonna divide C by C and then divide C by dy.
Why would I do that? I'm trying to get the y by itself. I don't care about the c. No, we can't subtract b because by is multiplication. That's b times y. Remember, two letters right together, it's always multiplication. You can't split them apart unless you divide. I don't know who that was at home that said subtract ax, but that's exactly correct. Ax is like saying 5x. We can subtract the whole thing. It becomes a zero pair. This ax, positive ax, there's no sign in front of it. There does not need to be a sign for positive numbers. They don't have to have signs. Negative terms always have to have signs. So I'm subtracting. And what I have next, what that leaves me with, by equals c minus ax. And how are we going to get the y apart from the b? Now we can divide. Yeah, by, remember that's multiplication. Every step in equation solving involves using the opposite operation. So if you see multiplication, to undo it, you got to use division. B times y is multiplying. So we have to divide both sides by b. Yep. And I'm not actually doing any division. Don't need to divide anything. I can't divide anything. Quit thinking that you got to come up with numbers.
That division on the C minus ax divided by b is both of them, right? It becomes a fraction.
Yep. You could split it apart. You could say c divided by b and negative ax divided by b, but there's no benefit to doing that until you know what some of the terms stand for. We don't have any numbers. There's no point in splitting them apart like that. So now we've got it in slope intercept form. If this was an actual, here, I'll give you an example of when we do this in the near future. This is what you're going to be looking at. there's an actual standard form equation that you'll probably see. There might even be one like that on this page. If you look down at number 18, I'll just do that one. I'll use those numbers. Because this is what we have to do all the time. It's negative 4y. And that should be 20. Okay, I got to do the same thing to get it in slope intercept form. I'm going to solve for y. So just like I subtracted ax before, I'm going to subtract 12x. Because that ax is a times x. This is 12 times x. So I can, if all I'm doing is canceling a whole term and to get it to the other side, then I'm going to use a plus for a minus or a minus for a plus. Because in this, even though this first term shows us as multiplication, it's still just a positive term. So whether you see that minus 12x as subtracting 12x or just the one being positive and the other being negative, it has the same end result. It creates a zero pair, which allows us to cancel it on the left side and then use it. It looks like we move it to the other side. So then we're left with, and minus 4x equals negative 12x plus 20. Now I didn't leave that minus 12x at the end because I know I'm trying to get this into y equals mx plus b format. So I put that x term right after the equal sign because the x term follows the equal sign in slope intercept. Now, one more step and I'm there. You know what to do, Kalpana? To get y by itself now? Divide by negative 4. And here, because I have actual numbers, I can do all those divisions. I like it when I can do that because those negative 4s will cancel. And I'll end up, let's see, 12 divided by 4. They're both negative, so my answer is going to be positive. Here I got positive divided by negative, so that's going to become negative. Yx equals 3x minus 5. Now it's in slope intercept form. I'm happy. I can graph it easily now.
So where did the 20 come from? That's where you
Look at problem number 18.
Right. No, like so it's 12x and then divided by negative 4, and then the 20 over negative 4. Where did that 20 come from? If on the next step up, you subtracted 20 minus
Because you don't really subtract it. You just
I'm not subtracting.
both down. They just add to
20 and 12x or negative 12x are not like terms. It's not 20 minus 12. That's 20 minus 12 negative x's. Those are not like terms. Here's what 20 looks like. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20. Here's what 12x negative x's look like. Seven. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They don't look alike. Can't subtract 12 from 20. Not when the 12 is 12 negative x's. 20 is just a number.
So then how did you get the 20 over negative 4? Did you just
What did I divide by?
We divided it by 4.
Okay, where'd that come from? I divided by -4.
-4y.
Yes, that's where that comes from.
So the -12x was moved down with even though it was canceled up there. I'm right there with
I'm like,
one
oh,
check to
yeah.
figure it out.
This equal sign here,
Uh-huh,
that's a doorway.
okay. Because I've got that in my head, what you do to one side, you do to the other.
And I did that right here. I subtracted, I put a -12x on both sides
Mhm,
because on the left side, I needed to cancel it.
right. So down on the other one, why is it over 4? I thought it was 12 come
Okay, hold on. The slope-intercept equation looks like number 6, problem number 6. This is the form I'm trying to create. You will have to do this starting next week. So at the point where I have canceled these x terms, what do I have left? I have -4y. All I did was move the -12x into the same position that it is in slope intercept because I know that's the form of the equation I'm trying to move it into. I already know that that's where it belongs. The x term follows the equal sign in slope intercept. We don't have to put it there, but you'll see why it's necessary when we go into the graphing. If I didn't do that, okay, let's say I forget about that, -4y. Let's say I didn't do that. It doesn't matter. Equals 20 minus 12x. Okay, same equation. Same as this. Order doesn't matter anymore in algebra. Not for this kind of stuff. Because that -12x is still -12x. When I put it on the right-hand side, what? What?
The 20 and the -12x. They're not like terms we can't combine them, is that?
Correct.
Oh, okay.
That, remember, to be a like term, it has to be the same variable. There's no variable with 20.
So
And-
if it was -4x and then 12x, you could combine those two.
If they were on the same side, yeah.
Right.
X's can go with X's, Y's can go with Y's, B's can go with B's, numbers can go with numbers. If I had more numbers than 20 on that side, I could combine those with 20. But -12x is -12 times x, or 12 negative x's. It's not just -12. That's why I made the 20 here be like sticks.
Mhm.
They don't look anything alike. The example I use all the time is apples and oranges. You go to the grocery store, you're going to buy apples and oranges. You got a bag of apples, you got a bag of oranges. You get home, how many apples and oranges do you have? Well, you still got however many is in each bag. You don't combine them all together and say, oh, I got 14 or apples or whatever it is, however you would want to combine that. Because if you're talking about fruit, you could do that. But if I ask you how many apples and oranges you have, you still have apples and oranges. You can't combine those because they're not alike.
Oh, okay.
What you got, Tony?
So I did number 12, and I'm not sure if I actually got that correct. I'm doing
Not as much.
Did you subtract 7x? Yeah, that's a good one. Tony's asking me about number 12. If you guys haven't looked at that yet, please do.
this is the answer I got.
Oh, what happened to, where'd the 14 go? What'd you do with that?
I divided that
By what?
by the 4.
Mm,
Or, wait, no.
Well, we don't do steps.
So if I divide it by the 7.
Sometimes it's okay to do some-
Should have got 2 then.
Oh, okay. I see why. Thank you.
I can't even remember my page.
Yeah.
I don't know where we should go.
All right, we'll do one more here before we go to start looking at some word problems. Oh, yes, word problems. It's the happiest day of your life, I can tell. So problem number 14 says solve for x. We're going to solve for x. 12, yeah, thank you. It's got 14 in it, so I got 14 on the brain. So solve for x. I want to add y. Huh. You're all wondering what? Okay, 7x equals y plus 14. Again, the term that I'm solving for is the thing I'm going to deal with last. That's the x that I'm solving for. So the other, anything else that's on the same side as the term I'm solving for has got to go. Cancel it, move it, add it, subtract it, do something with it, get it to the other side. Get it through that doorway. And the only way to go through this spot here with the equal sign is to use opposites. So here's this 0 pair of y's that cancel each other out. One negative y and one positive y equals 0y. 0 times y is still 0.
Man, die ben ik.
So this actually is only a 2-step equation because now we just got to divide everything by 7. And it's going to look really funny. And I'm going to see who can figure this out. X equals 1/7 y plus 2. I'm blowing your minds now, I know. Yeah, I'm going to back it up here. Just 1 second. So the 7s would cancel on the left. So we got x by itself, right? Y divided by 7. Can't do it. So we leave it. Plus 2. We've solved it for y.
You make it for 1 because
Y doesn't, we don't know what y equals. How do you know that y equals 1? Does it say that?
no, what, why did you get that 1 over 7?
It's the y over 7.
Oh, no, at first. Why did you put 1 over 7?
Yeah.
Just to throw us off?
No, I'm going to make a point here. Eventually, I'll get around to it. Yeah.
But wait, so the first thing you wrote is still correct?
These are both the same.
Okay.
So, because 1 is always like at least a variable. Like a variable is always 1.
You guys are overthinking this right now because what's the difference if I say I'm going to divide y by 7 and taking 1/7 of y? Because isn't this 1y? There's your 1/7. It's similar to
But it's on.
this. I love math. I love this kind of stuff. You guys probably think I'm completely nuts. Think about sharing $1, splitting $1 with somebody. You're gonna take half of it, or you're gonna divide it in 2.
50 cents a piece.
It's the same. That's what I just did. I took 1/7 of it, or I divided it by 7. You'll figure this out. Don't worry about that for today. Process is everything. If you got anything that looks like this, even without the 1 in front of the Y here, you're good. Because you did it right then. There'll be, see, and this is where I really miss having the extra class time that we don't have during the pandemic, because we could practice on this stuff more. The good news for y'all is there's only probably 4 problems like this maybe on this unit test.
I did everything right until it came down to writing the answer I should put. So I got almost everything else right except for the
Well, if you want more, if you want to do some more of those on your own, and then maybe you know, send me a picture of it or something, I'll be happy to give you some feedback on those.
Can we go over one of the division ones?
Sure, which one?
Um,
19?
17, because the numbers when it's all, or not numbers, when it's all letters, is what's throwing me off. Either 17 or 20. 17.
Yeah, I hear you, Chase. Thank you. Chance, I'm sorry, not Chase. 17? Okay, because that's a mixture, mostly letters, but it's got a number in it. All right, 17. Capital A. Here's a, and this is a good one for another reason. We got a lowercase a plus b plus c divided by 3. Well, I know those A's are both the same letter of the alphabet, but they do not refer to the same thing. Those are actually different variables. Capital A means one thing, the lowercase a has to mean something different. Now, most people will not write equations with the same letter in them like that. Scientifically, though, sometimes you can't avoid it. So this is very much like the, let me see here. Just like this problem, B equals A plus M over 7. Okay, what are we going to do to get rid of the fraction? By what? Yep. That's the easy part. So we got 3A over there. 3's cancel on that side. 3 capital A. Plus B plus C. Okay, and I'm solving for B, so now what? Okay, I like subtracting C. What else? Let's do it all at once. Subtract the lowercase a and subtract the C. Yep. Minus A minus C. So those cancel. Now over here, we got 3A minus little a minus C equals B. And all we did was use opposites every step. Yeah. We solved for B. That's what we were told to do. That's what the problem suggested. I did 2. I mean, you could do it in 3. You could subtract one of the letters on the right and then rewrite it and then do another letter on the right, rewrite it again. But I'm going to be basically lazy like that and look for a shortcut whenever I can. Khan Academy's got some really good videos on this kind of stuff too. We're not going to do it for right now, but if you look at I would encourage everybody to try to check out problem number 9. Does anybody recognize that formula, that equation? Right, that's a volume calculation. Yeah, for rectangular or for rectangular objects. If you got to put water in a swimming pool, you're probably using a calculation like this to figure out how much volume that pool is going to hold. That's a very common thing that's used. The very first one, P equals IRT.
Oh, crap.
Anybody remember that?
I know what it is.
P equals IRT. I'm not trying to solve it. I'm just asking if you recognize the equation.
It has to do with like time or something. doesn't it?
Yeah, it's got time in it. The time is the T.
Time, rate.
And interest.
Yeah.
Interest times rate times
It's
time.
like banking and stuff.
Yeah. If you're going to get a loan, that's where the calculation is going to come in to figure out how much you're going to have to pay them back.
I knew it was.
Yeah, good job. This first handout starts off with a lot of terminology in it, a lot of descriptions. But it's there for a reason. Hopefully that's a little bit more visible. Right above the boxes there, you can see some of the terms I've been using a lot already. Variable, constant. Constant would be like the number 20 in that last problem with the previous problem. Coefficient, I will use that term all the time because it's the number that modifies X or Y or B or whatever the variable is. Sometimes it's another letter. The thing that is helpful about this table is if you got a word problem, how do you know what operation that you're using? Remember, there's only 4 operations: add, subtract, multiply, divide. I don't care how complicated people try to make stuff look, eventually you're going to have to do those 4 operations to solve a problem. So there's lots of different ways to describe in a word problem what kind of a problem it is. So the traditional, like for addition, the traditional term sum tells you that's an addition problem. The sum of the parts is greater than the whole. That's an addition problem, if you've ever heard anybody use a phrase like that. All these other words are also going to tell you it's addition. This and that equals something. This increased by 10 equals something. 6 more than that, addition. More than, plus, total. Total is used a lot of different ways. Combined. This and this, this and that were combined. Okay, you're going to add them together. Subtraction, somewhat similar. The traditional word in subtraction is the difference. The difference between my bank account yesterday and today is blah. It's not enough. That's what it is. Less than, decrease by. And what you notice here, but between these 2 columns of addition and subtraction, there's a lot of opposites. Decrease by is opposite of increase by. More, opposite of less. More than, opposite of less than. Well, that makes sense when you think about addition and subtraction being opposites, right? They're inverse operations. One undoes the other. Lower than, minus, fewer than, those are all different phrases or words you might see in a subtraction problem. The multiplication and division columns kind of work the same way. Here, I'll put this one highlighted. When we're doing multiplication, we get a product. How and this is another part that I like about this kind of stuff, is how can double and half both be multiplication? Well, we can still multiply by 1/2, can't we? Yeah. When we multiply by fractions, a half, a quarter, a third, it's still multiplication. Just got to remember how to do fraction multiplication. Double would mean 2 times, right? So times, triple, twice, all those could mean multiplication. So then division is going to be the opposite. And it's got the strangest of the words for the traditional answer, which is quotient. The last column, I'm going to add total. Really should be there. When you see that any of those words, equals, is, was, are, were, gives, yields, total, that's where the equal sign needs to go in your problem. And I'll give you a clue here also. All of these word problems that we're going to work with are basically 2-step equations. So for us, we're going to have a specific format. I've highlighted in blue there. We're going to have a coefficient, variable, and plus or minus a constant. And then we're going to have a total. So all kinds of different ways to write equations and to solve equations from word problems. Everybody must find their own way they're comfortable with. If you really struggle, the thing that I recommend is find the total first. Well, in this one right here it is. This is a car repair problem. Miss Sylvia pays $370 in total. So I don't know anything else about this problem yet, but I know she's paying $370 total. So what else do I have? The mechanic charges a flat $70 fee plus $30 per hour. Okay, 2 other numbers. Is one of those a variable?
No. Cool.
Think again.
Yeah,
$30 per hour. Here is another key word. This is probably what drives people crazy about English. Because per could also mean each or every or per hour, 65 miles per hour, $30 per hour. That's a changeable amount. It's going to change depending on how many hours somebody works. So there's my variable right there. And so I'm just going to write 30H. The 70 will go next. It's a one-time charge, 30H plus 70. Boom, you got your equation. Now you're able to figure out how many hours the mechanic worked on the car. And the question that you're trying to solve is another clue to the variable. We don't know how many hours. Remember, variable can be changeable or it can be an unknown. So when the problem asks you how many hours did the mechanic work on the car, and you look back here and you see that it's $30 per hour, there's a changeable amount. You know, if it's 2 hours, it's going to be 30 times 2. If it's 10 hours, it's going to be 30 times 10. Oh, I just gave away the answer. Yeah, you said Jay. I heard it. Yep, that's right. Thank you. And so the solvent is just the same as all these other ones. Now 30H equals 300. Divide by 30, you're done. So now you know it took 10 hours to fix poor Miss Sylvia's car. Now there are some things that might trip you up a little bit on the way some of these problems are worded. Maria bought 7 books to add. That's out of order. typo, to add to her book collection. A week later, half of all her books were destroyed in a fire. There are now only 22 books left. How many did she start with? Okay, well, if we wanted to start with the total, start with the end and work backwards, I think this is the total here. Now she has only 22 books. So I'll start with that, 22. Maria bought 7 books to add to her collection. So she bought 7 and added them to something. Do we know what she added them to? Okay, that's the variable. There's your unknown. That's why I asked, do you know what they were added to? Well, no, we don't know. And again, at the end here, it says, how many did she start with? Well, that's whatever that was, she added 7 to it. 7 plus x, not 7x. She added 7 books, not 7x. 7x is 7 times x. A week later, half of all her books were destroyed in a fire. Okay, so no. Not yet, not yet. And I can't seem to draw a line on this, but this 7 plus x is now a quantity. That's one of those compound fractions, complex fraction. Our variable's tied up in the quantity. Whatever she added 7 to is now being divided by 2. So how do we get rid of the fraction? Multiply by dos. Do. 2. Multiply by 2. We do that finally, we get 7 plus x equals 44. And now we can figure out easily how many she started with, which will turn out to be 37. I multiply both sides of this by 2. I don't have any way to scribble it on here on this Google Doc yet. So sometimes how you write the equation is a question of timing. You know, did they lose something right away, or did they lose half of it right away, or did they add something and then lose something? Like dropped them in a pond. You see a bunch of word problems like that we have as examples. So again, I'm following the same process. I used the opposite here to get rid of this fraction. The final step would be to subtract 7 from both sides. Now, if I'm still not sure I got the right answer, how do I check it? Well, I just solved it. It says now x is 37. So go back to the beginning. 7 plus 37. All that divided by 2 has got to equal 22. I'm pretty sure it does. 7 plus 37 is 44. Divide that by that number by 2 and you got it. Questions, anybody? I want to do this one with Mr. Lance here. I want to talk about Mr. Lance. I want to make fun of him. I don't know who that is, so it's okay. God, I hope it's not him. I don't want to talk about him. A cheater. I was a huge Lance fan too until I fessed up finally. I had to throw out all my Lance Armstrong gear. A nice yellow Nike sweatshirt. Man. Okay, Mr. Lance is going to Hawaii. It will cost $800 to fly, and the hotel will cost $40 per day. How many days can Mr. Lance spend in Hawaii if he has $960 to spend? Two-step equation, right? Variable plus a constant is going to give us a total. So how do we want to start writing this equation?
40
Per day?
per day.
Good. I like it.
Plus 800 equals 960.
Yep, that's all you got left. Now, I feel bad for Mr. Lance here because he's going to Hawaii and he's only going to spend $40 a day on a hotel. I mean, what is he going to get? It's not even going to be like a day's in. Oh my God, it'll be something terrible.
Well, actually, there's Airbnb where you can rent out one room and
Never thought.
In Hawaii, even? Oh my gosh, I find that hard to believe.
But one person has a house, so you only get one room
Oh, yeah.
of the house. But
No, I've done Airbnb a few times, but never that cheap.
yeah, it's just one room. Normally when you get Airbnb, it's the whole house, but now homeowners can offer one room.
Oh my gosh, wow, $40. Well, maybe he's smarter than I think he is. And Tony's already flashed me the sign of the answer. So I think anybody else got an answer to share? And I'm going to make fun of Mr. Lance here for another reason too, when you guys realize how long he's there. Not quite. Calculation's a little off. Yes, Jess. Oh, okay. She's got the same answer. Good. I get the sign now.
Oh, it's one day out.
Yep. Hopefully everyone got 4 days. If you're going, if say Mr. Lance is from here, if you're going to Hawaii, I hope you spend more than 4 days because it's going to take you a day to get there and another day to get home because you got to go to LA or Portland or Seattle or somewhere to fly over. And that's a long day. And you're going to be jet lagged and you got to fly across all those time zones. So spend a week at least, $40 a day. Come on.
I'm gonna go, get off the plane, turn around, get right back on the plane. If you're from
Used to
India,
say I went to
you
Hawaii.
better stay there a lot longer than you plan to.
For sure.
Especially since it's not.
All right, let's do the last one here with John's TV. And then I want to talk about Miss Betsy's dog being on a diet. So I'm going to pause and give you guys a chance to work on that last one with the television. All right, good job today, everybody. We'll see everybody on Tuesday.
Bye. Thank you,
All right, see y'all. No, I stashed them. I'm going to take them home and eat them this weekend. Thank you. Appreciate it.
I'll probably reach out to you this weekend with some of those problems.
Okay.
Because like I get
Bye.
like the first